Hello again, Year 11. This is the last video on the chapter I'm going to make. This one relates to exercise 14.0. It's called Applications of Trig Functions. So I thought the way to do this, to show you this, was actually to just to do the worked example. But even though it's a worked example, I don't think when they set it out in the book they did a particularly good job of actually explaining what's going on. So I thought I would do that one with a bit of extra explanation, and it should be enough for you to actually keep doing problems of this type. So the example reads, more or less, the height h of t meters of the tide above sea level at Warnung on the 1st of January is given by the rule h of t equals 4 sine pi on 6t. Okay, so the first thing you want to look at when you look at this function is to see that this n value is a pi over something, okay? And it's usually pi over 6, okay? It can be pi over 12, but it's either pi over 6 or pi over 12 for these type of problems, where t is the number of hours after midnight. So 0 is midnight, okay? And the first thing you're asked to do is to draw the graph of that function, h of t, between 0 and 24. So like any trig function, the first thing we've got to do is we've got to look at this function and say, well, what's our amplitude? Our amplitude is 4. That's easy. That's that coefficient. And this is n, so the period is 2 pi divided by pi over 6, which is 2 times 6 over pi. And what do you know? The pi's cancel out and you get 12. And this is not unusual for a tide question because tides usually occur between 11 and 13 hours. So they've given us a question where this tide comes around every 12 hours. Or it's actually for a particular day, so tides are approximately 12 hours apart. In this question, exactly 12. But the thing you want to know for this, or the thing you want to appreciate for this, is that in the range 0 to 24, that represents 2 periods of the graph. Now for us to draw it, I'm just going to have to tilt this a little bit. Maybe I should do that. For us to draw it, okay, I've set myself up a little stencil just to keep the video a bit shorter. Okay, what I've got here is this is the t-axis, so I should label it the t-axis there. Okay, and this is h. Remembering that this is positive 4 and this is negative 4. Okay, it's a sine graph. Now, sorry, if one period is 12, I'm drawing in 2 complete periods, and I'm starting here. So the graph just looks like this. I'm going to just do a bit of a trace of it there. You go there, there. Drawing sine graphs freehand is always a bit tricky. Like this, up here. Yeah, I've done this before. You should try this at home, absolutely. And there it is, okay? So that's it's freehand, you can tell, but that's the sketch of the graph. And I've got 2 periods. You see, I drew myself in some nice guidelines, and I actually marked in these points and just sketched between those points. Of course, you can do this on a CAS, and I will do this on a CAS in a moment, because the last part of the question actually works really well on a CAS. In fact, it's really the only way to solve it, especially when you're in a bit of a hurry. So part B of the question in the worked example is, when was high tide? Okay, so high tide is just here, these peaks. Right. Now, if you've drawn your graph properly, you've got one period between 0 and 12 and another period between 12 and 24, which means that is 6, which means this is 3. Okay, so this is 3 hours, 3 o'clock in the morning. And this is 1500 hours, and 3 o'clock in the afternoon. So this is, we can actually write, I've written it in 24-hour time. This is 3 a.m. and this is 3 p.m. Okay, that's when we've got high tides. Alright, actually let's push that up. I've just realised that's not in shot. So high tide is here, that's 3. High tide is here, that's 15, because that's 0, 0, 6, 12, 18. Okay, so 3 a.m, 3 p.m, it shouldn't be too difficult to see that. part C of this question. If it was an exam question, I wouldn't be giving more than about half a mark for this. What was the height of high tide? Hang on, down. What was the height of high tide? It's just the amplitude, 4 metres. Okay, it's the amplitude of 4 metres. That's it. Part D, what was the height of high tide at 8 a.m.? Okay, now we're working off a 24-hour clock here. So this is our original function, h of t equals 4 sine, and I've just substituted in 8 here. 4 sine 8 pi on 6, which you can cancel that down. That becomes 4 sine 4 pi on 3. So if we jump over here, 4 pi on 3 equals negative sine pi on 3. Okay, what's the sine of 4 pi on 3? When you see this 3 fraction here, you should immediately be thinking things like unit circles and standard triangles. The sine of 4 pi on 3 is negative root 3 on 2. Okay, and I haven't just pulled that out of nowhere. I'll show you where I got that from. I got that from here. Here is our unit circle. This is in the first quadrant. This angle is pi on 3. Okay, and the sine of pi on 3 is root 3 on 2, and it's positive in the first quadrant. Don't believe me? Here we have my standard triangles. Okay, this is pi on 3, 60 degrees. Okay, it's the sine is opposite over hypotenuse, root 3 on 2. Okay, this comes from a few videos ago. It's in my table. Sine theta, sine of pi on 3 is root 3 on 2. So, I'm sure I've convinced you now. The sine of that angle is root 3 on 2. Now the sine of 4 pi on 3 is over here in the third quadrant. Okay, so in the third quadrant, this is sine is negative. So that's why I can sit there and say, yep, the sine of 4 pi on 3 is negative root 3 on 2. Okay, so, but what we're dealing with here is we're dealing with 4 times the sine of 4 pi on 3. Okay, so when we sub into this equation, we've got 4 sine 4 pi on 3. So we've got negative 4 root 3 on 2, which cancels down to negative 2 root 3 metres. So negative 2 root 3 metres is the height of the high tide, or it's the height of the tide, sorry, at 8 a.m. Now, in the textbook, they leave that as an exact answer, negative 2 root 3 metres. Now, I don't know about you, but if you said to me, I need to know when the tide is at negative 2 root 3 metres. It's low tide at negative 2 root 3 metres. So, well, how many metres is that? We don't actually know. We don't naturally understand what a value of negative 2 root 3 is. Okay, so I've just got that as an approximate decimal using CAS and saying it's approximately 3.46. You could say approximately 3.5 to one decimal place. It's 3.46 metres below average mean sea level, average sea level. So that's height of the tide. I shouldn't say high here. I just realised I've said height. What is the height of the tide at 8 a.m.? Now, the last question in the worked example. This is the tricky one. It's always the way. I've just grabbed my book because I want to read the question as it's written. It says, a boat can only cross the harbour bar when the tide is at least 1 metre above mean sea level. When could the boat cross the harbour bar on the 1st of January? So when you're reading a question like this, you've got to actually realise how much of that information you don't actually need to mathematically solve the question. Okay, so you've got basically they're asking when is the tide above 1 metres on that day. Now, when you look at the way the worked example has done it, it almost seems like they've pulled the numbers out of nowhere. Okay. And the way they've got the answer there is not very helpful at all. So, seeing as I am quite helpful, I'm going to show you how it's done. Okay, what you need to do is you need to go back to your graph. Where's my graph? It's over here. All right. Now, I'm going to show you on here, but then I'm going to show you in a much better way. So, we want to know when is the tide above 1 metre. So on this graph here, I'll move it, sorry, it's not in shot. I'll move it up. Here's my graph, okay. When is the tide above 1 metre? It is, 1 metre represents about there on the graph. And I'll go to the other side, sorry, I'll slide it back up in a second. I'm going to mark that there on the graph, and I'm going to draw a line between those 2 points. Alright, so I've got that there. Let me show that to you again, make that nice. Alright, so this represents 1 metre. Because we want to know when is the tide above 1 metre. So we need to know this point here, and this point here, and this point here, and this point here. Because in this time interval, between there and there, the boat can cross the harbour. And between this time interval, in this time interval, between there and there, the boat can cross the harbour. Okay. Now, if you're asked to do one of these, we're not going to ask you to do one of these in a test that doesn't allow you to have a CAS with you. Okay. So what you have to be thinking when you get a question like this is, all right, how can I use my CAS to solve this? So I'm going to show you that. Now, I'm not sure how well this is going to come out. I don't actually have the software. So let's see. Can I do this? It doesn't work beautifully, but alright. So let me just get to the right screen and I'll put it up for you. Should have had it there ready. Listen, what are you doing? Alright, here it is here. Okay. Let's try and get it in shot. Okay. So what I've done, I've got the red graph, that's the function. F of x, f2 of x is 4 sine pi on 6x. Okay, so you can see the red graph that I've drawn there. And then what I've actually done is I've drawn a second graph on there, and that's just y equals 1. So I've actually already found 4 of the plotted intercept points there. 3 out of 4. Okay, there's 4 points. So I'm going to find the last one. I don't know if I can do this. What you do is you say menu, okay, analyze graph. Oops, not table. Come on. It's because of the angle I'm on. Okay, and you want the intersection. And you want this intersection here. So I'm going to click there, drag across to there. And you can see it's put it in. And it's a little bit difficult to see because the function's over it. But you can see these two here, 0.4831, 5.521, 12.51, and the other one's a little bit difficult to see. Okay, but I'll have a look there in a second. So you can see the y coordinates on all of those is 1 because it's intersecting with y equals 1. So we want those x values. Okay, so that is really the way to do it. You draw the graph in the CAS. That's just the original equation drawn in the CAS. Okay, and then you draw a line y equals 1 because you want the intersection when y equals 1, and you just use your CAS to find those 4 points. So I'll take this away because I can actually just write these now. When is it there? I'm working on this page here. Okay, so when is the tide above 1 meters? It's between x equals, when x is between it turned off. I love when your CAS is trying to save battery like that. 0.483 and 5.52, and when x is between and it's 12.5 and 17.5. Okay, 12.5 and 17.5. So these are times. So this is after midnight. Okay, and this is between 5 and 6 a.m. Right, but it's decimal. So to do times there, you've basically got to turn that into minutes. So 0.483 times 60. Let's do this. 0.483 times 60 is 29 minutes, I'm going to say. So this is at 12:29. Oh, not there. Well, actually, so this is 12:29 a.m. and 0.52 times 60, because it's 0.52 of an hour. 31, 12:29 a.m. and 5:31 a.m. we'll say. So that's the first period, and then you've got 12.5 and 17.5. You've got 12:30 p.m. and 5:30 a.m. Okay, so I think there's some rounding in there. I'm going to check that against the book's answers actually. Yeah. So what they've got here is they've got the boat can pass across the harbour between 0:29 they've got 0:29. I've got 12:29 a.m. but anyway, and 5:31 a.m. So that first one's right, and then the second one, I think because the calculator only goes to 2 decimal places, I've got 12:30 to 5:30. They've got 12:29 to 5:31. Okay, so that is an issue of rounding there. Yeah, so there is a slight discrepancy there. Okay, I think if this was set as a task, then we would be saying, well, depending on the method they use to solve it, depends on the accuracy there. So if I was doing a marking scheme there, I would allow 12:30 to 5:30 for an answer when we've got 12:29 to 5:31. But certainly, when you look at the worked example in the textbook, it doesn't actually give you any idea how they came up with these numbers. They come up with the numbers 0.48. They've got it to 4 decimal places. They've got 0.4824, 5.5176, 12.4824, and 17.5173. And they're not clear on where they got those numbers from. All right, and that's no good to you. Well, how are you going to get those numbers? You're going to get those numbers by using your CAS and plotting the intercepts like I've done. So hopefully that helps you out and gives you a start on solving these things. Get in, have a go, do as many of them as you can. The better you get at these, like if you can do, the more of these you can do, the better off you are. And this is really as tricky as it gets in terms of applications. So signing off.